Good morning, dear students. Welcome to this session on moment distribution method. So I'll just go back to the last sessions. What are all required for moment distribution method to carry out? So you need to know carryover moment. So what is carryover moment? Is when you apply moment at one end. If the far end is fixed, some moment will be carried forward to the fixed end. That is called carryover moment. And then we have defined carryover factor. Okay, so that is nothing but carryover moment divided by moment applied. Okay, so when you apply moment m at one end, the far end of the member, if it is fixed, then some moment will be carried to the fixed end, which means some moment will develop at fixed end. That is called as carryover moment. So the ratio of carryover moment and applied moment is called carryover factor, and we have calculated the value of carryover factor as 1 by 2, which means if you apply some 10 kilonewton meter here, if the far end is fixed, the moment developed at the far end is half of the value applied. That means 5 kilonewton meter is the moment developed at far end if it is fixed. Okay, so that is what is meant by carryover factor. Coming to the stiffness of the member, so we have derived the value of stiffness of a member if the far end is fixed. Okay, that value is 4 EI by L. Okay, so stiffness is nothing but moment required to rotate a point by a unit angle is known as stiffness. So what is the stiffness value here? 4 EI by L. This is valid only when far end is fixed. Okay, so this is what is done. Similarly, we have derived the formula or mathematical expression for distribution factor also. What is called as distribution factor can be calculated with this formula, which is Ki divided by sigma Ki. Okay, which means stiffness. If you want to know distribution factor for member OA, okay, that means you must calculate stiffness of that member KOA. So you know how to calculate stiffness, right? 4 EI by L if the far end is fixed. Okay, divided by total stiffness at the joint sigma Ki. Okay, right? So this is for OA. Similarly, for all other members, you will have distribution factor for each member. Okay, so nothing but what does it mean that nothing but if you apply some moment m here, say this is something like 100 kilonewton meter at a joint. So if this distribution factor of OA is equal to some 0.25, for example, if you get it, Okay, so moment shared to OA is equal to 25, 0.25 into 100. Okay, MOA, moment shared to OA member is M into distribution factor. That means 0.25 into 100. Okay, so that is the importance of distribution factor. Means when a moment is applied at a joint, how much moment that a member can share, okay, that will be decided only with the help of distribution factor. Okay, right. So this is how distribution factor is calculated and used. Okay, so this is what is distribution factor. Share of a moment share of a particular member at a joint, okay, will be decided based on distribution factor. Okay, moment share of a particular member at a joint, okay, will be depending on distribution factor. And these are all the expressions that we derived: carryover factor, carryover moment value, and stiffness value, and distribution factor formula, right? So this is all happened in the previous sessions. So what are all required for to proceed with moment distribution method? So now let us see what exactly is to be done when you are having a problem of to solve a given problem in the structural analysis with the help of moment distribution method. What needs to be done? Step by step procedure. Let us. Okay, so first you need to assume all the nodes as fixed and then calculate fixed end moments. Okay, so first step to do, step one, is you have to take all the members in the structure as fixed beams. Okay, assume all the nodes as fixed, right? Every point, the end points, every end point of a member is called say node, right? So all the nodes, end nodes, I mean to say, end nodes, you should assume they are fixed. For example, so if this is a continuous beam having three supports, for example, just a minimum case of this thing I take. So select A, B, C is a continuous beam. Right, so if this is the given beam and if I ask you to solve this problem and draw BMD or SFD something, what you first should do is take AB as fixed beam. Okay, this is AB. Similarly, take BC as fixed beam. So you must take all the members as fixed beams. Say if there is a load here, if there is a load here, something like this, same loads you take it on the beam, then write fixed end moments MFAB, MFBA, and MFBC, and MFCB. Okay, so that is step one to start with. Okay, so if you are given a problem in moment distribution method, first in a given structure that must be taken as every member is a fixed beam. Okay, then from the given loads on the fixed beams, you try to write fixed end moments, and all the fixed end moment values we have been tabulated in the earlier session, or else I told you to refer back to your uh, slope deflection method, where all these fixed end moments are available for all the cases. Okay, got it? Okay, right. So let's go to the next step of the procedure. Okay, then what to do? Calculate distribution factors for all the members at a joint. So now you identify the joints in the structure. So in the given example of ABC continuous beam, do you say A is a joint? No. Reason, there is only one member there. It is not a joint. Do you say C is a joint? No. Do you say B is a joint? Yes. There are two members meeting at B. Okay. So now identify the joints. So B is a joint for me. Okay. So B has got two members. One is BA, another one is BC. Okay. So now calculate distribution factors for these. Distribution factor for BA and distribution factor for BC. Okay. Right. Now, so that is the step 2. So step 1, we have got fixed end moments of all the members of all the ends. Fixed ends, all fixed ends, we have moment values. Then next step we have done is to calculate distribution factors. So how to calculate distribution factor? So before you calculate distribution factors, what you need? So distribution factor formula, if you observe, so what is required is stiffness of that particular member divided by stiffness of the joint. Means what? Stiffness of summation of stiffnesses of all the members at the joint, right? So there are only two members at the joint now in this example. So this is distribution factor for BA. K of BA by K of BA plus K of BC. So before you calculate this one, you must calculate stiffnesses of all the members for the ends that you are taking. So KBA. So you have to take BA. A is fixed. So B must be released. Okay. So what is K for this? You have to estimate. How you estimate K again? 4 EI by L. So you will be given for AB member in the given problem. You will be given with the values of EI and span L. All these will be given data. So you must be able to estimate K value. Similarly for BC also, same case. Okay. So this is how it is to be done. Okay. Right. Once you find distribution factors, okay, then what next? Balance a joint by distributing balance joint by distributing balancing moment to various members meeting at the joint proportional to their distribution factor. For example, if MBA is say 30 kilonewton meter fixed end moment, say MBC is equal to some minus 50 kilonewton meter. What is the total moment at B? It is minus 20, right? Minus 50 plus 30. So minus 20 is the total moment at B. What should be moment at B? B is a hinge, right? Moment should be 0, but what you are getting? Minus 20. So this shall be made 0. Okay. So to make minus 20 0, okay, what you shall do? You have to apply plus 20. Okay. So plus 20 shall be applied. So how do you apply this 20 for the two members there? So this is applied moment, right? Plus 20. So how do you apply? If the distribution factor of PA is say 0.4, distribution factor of BC is say 0.6. Okay, now plus 20 shall be applied to BA with value 0.4 times 20, which means how much? 8. BC, how much to apply? 12. 0.6 into 20. So this is how you apply the moments so that the joint will be balanced. Now you see 30 plus 8. How much? 38. Okay. Minus 50 plus 12. How much? Minus 38. What is total value? 0. Okay. That is how it is done. Okay. So balance a joint by distributing balancing moment. What is balancing moment? This is the one which is balancing minus 20. So minus 20 is remaining value. Okay, the remaining moment there. To balance what you are doing, you are applying some balancing value. Okay, so this is balancing moment. So the balancing moment shall be distributed to various members meeting at the joint proportional to their distribution factors. Repeat this procedure for all the joints, not only joint B. If you have some other member CD, and C also will become joint now. So likewise to all the joints you must uh, perform these things. Okay. So there is a note here that fixed end is self-balancing. You need not balance if there is a fixed end. Okay, right? Fixed end automatically balances himself. Okay. For example, if you apply some 30 kilonewton meter to the fixed end, the fixity, the support itself will develop minus 30 and balances it. So that's why you don't need to balance fixed end, right? Then what next? Carry over half of the distributed moment to the far ends. Imagine that in the given problem, A is fixed. Imagine. So what you are doing, you are applying 8 here. Okay. And if the far end of B in AB, B is near end where you are applying the moment. Location where you are applying the moment becomes near end. Okay, so in AB, you are applying moment at B. So this is near end and this is far end. Okay, so you are applying 8 kilonewton meter here. So half shall be carried to A. Okay, so 4 will be carried to NDA. That is what is called carryover moment. Okay. So similarly, if there is a joint at C, right? So here says there is some moment say 10 to balance the joint C. You applied 10. So half will be carried to B. Means 5 comes here out of 10. So what happens? You have made 38 minus 38 0. Then what happened? The other giant, when you are balancing, the half of the value is carried to far end, and this is again disturbing the balance of giant B. So 5 is disturbing this balance. So what you have to do, again you have to make it 0 by adding minus 5 to this. Okay, right? Now it is 0. Again what you will do, as you are applying minus 5, that minus 5 shall be carried to far ends again, BA and to C also, because C is also far end, right? So likewise, as you balance the two giants or three giants or four giants, the balance of one giant will be disturbed by the other giant because of carryover moments. So carryover moment will be carried from B to C and C to B. So they will unbalance the giants. So till how much, how many, no repetitions you have to do to balance such giants is repeat balancing and carryover till required convergence is achieved. Means, so you go on balance one giant, carry to the far end. Again, you balance this and carry to the other end. And you balance that again and carry to this one. So likewise, you go on, do it, repeat it until what? The balance is, say for example, you set some value. Say I want balance to be 0.01. Okay, nearer to 0.01, then I will stop. Okay, so this is what is called convergence. Okay, right? So that is the repetitive process. Okay, right? And then finally calculate sum of all the moments at a particular end, so that you will get final end moments. So as you go on carry so many values from B to A for all the trials, trial 1, 2, 3, 4, 5, like that. So all the values at A, if you add, you will get MAB value, moment MAB value. Similarly, if you add all the values at B, you will get MBA value. Again, to this side of joint, if you calculate all the values, you will get MBC. And if you add all these values to this end of C, you will get MCB values. So likewise, all the end moments you will be getting finally, right? So this is the procedure, right, to follow moment distribution method. So this is very simple. Just to add, no, divide the values, add the values, or deduct the values. So it is like, simple mathematics, right? So, but you have to understand clearly what is to be done. You must have clarity what is to be done. If you have command over each step, then this will be very easy. Okay. Right, we'll come back to the next session with an example. Okay, thank you.